Welcome to our video magazine entitled Architrigoneer. This magazine is about the applications of trigonometry in the field of architecture and engineering. Next, on the first page, you will see the trigonometry and railroads. As far as possible, railroads are constructed in straight lines except where a change in direction is necessary to get the desired grade or to reach such a point that is not in a straight line. It is accomplished by curves. Railway curves, except transition curves, are uniform in nature such that for any unit of length traveled around the curve, there is the same amount of change of direction. The minimum railway curve radius is the shortest allowable design radius for railway tracks under a particular set of conditions. It has an important bearing on constructions, costs, and operating costs, and in combination with super elevation, which is difference in elevation of two rails. In the case of train tracks, determines the maximum safe speed of a curve. Minimum radius of a curve is one parameter in the design of railway vehicles as well as trams. Monorails and guideways are also subject to minimum radii. The first proper railway was the Liverpool and Manchester Railway, which opened in 1830. Like the tram roads that had preceded it over 100 years. The L&M had gentle curve and gradients. Among other reasons for the gentle curves was the lack of strength of tracks, which might have overtuned if curves were too sharp, causing derailments. There was no signaling at this time, so drivers had to be able to see ahead to avoid collisions with other trains on the line. The gentler the curves, the longer the visibility. The earliest rails were made in short lengths of wrought iron, which does not bend like later steel rails introduced in the 1850s. In the United States, circular railroad curves are designed by the degree of curvature, the central angle subtended by a chord of 100 feet.
Good day. I'm Architect Christine and I'm planning to build a circular railroad around a theme park. Here is a simple sketch of my plan. The theme park has two intersecting roads at the center. If I would be dividing the angle theta into two, then I would be having half angle thetas. Now we use the figure to write an expression for cosine theta over 2. Using the half angle identities, we can express cosine theta over 2 equal to positive or negative square root of 1 plus cosine theta all over 2. Now that we have this expression, we can use it in the third half angle identity for tangent to write an expression for tangent theta over 4, which would produce tangent theta over 4 equal to positive or negative square root of 1 minus cosine theta over 2 over 1 plus cosine theta over 2. Now let's try assigning values in the half angle equation to determine whether the positive or the negative square root should be selected. Consider the equation sine of 195 degrees is equal to positive or negative square root of 1 minus cosine 390 degrees over 2. The objective is to determine whether it is equal to positive or negative square root. We know that sine theta is equal to positive or negative square root of 1 minus cosine 2 theta over 2. So we let theta equal to 195 degrees. This implies that that sine 195 degrees is equal to positive or negative square root of 1 minus cosine 390 over 2. And we know that theta is equal to 190, which is in the third quadrant. So since theta lies in the third quadrant, the sine function is negative. Hence, we should have to select a negative square root, producing the equation sine of 195 degrees is equal to negative square root of 1 minus cosine 390 over 2.
This video is brought to you by McDonald's. Sa bari ko, lumipas na ang pagsusulit ng araw. Dahan-dahan pang tinatanggap ang aking maling sagot. Muntik na nasanay ako na laging pumapasa. Muntik na akong bumasa, ngunit di pala kinaya. Tuloy pa rin ang try ko ng summer ko. Nagbago man ang radius ng cardioid mo. Handa na akong ulitin ang Precal 2 pagkatuloy pa rin. Kung minsan ay nahanap ang sagot sa aking pagkakamali, inaamin ko na kay tagal pa ng susunod na exam. Kaya ngayon ako'y mag-aaral upang ako'y pumasa. Tuloy pa rin ang summer ng buhay ko. Matutuwa sa akin ang nanay ko. Hindi na ako magmumukmok sa kwarto pagkatuloy pa rin. The significance of trigonometry. Trigonometry in marine engineering. In marine engineering, trigonometry is used to build and navigate marine vessels. To be more specific, trigonometry is used to design the marine ramp, which is a sloping surface to connect lower and higher level areas. It can be a slope or even a staircase depending on its application. Trigonometry and flight engineering. Flight engineers have to take in account their speed, distance, and direction along with the speed and direction of the wind. The wind plays an important role in how and when a plane will arrive wherever needed. This is solved using vectors to create a triangle using trigonometry to solve. For example, if a plane is traveling at 234 miles per hour, 45 degrees north of east, and there is a wind blowing due south at 20 miles per hour, trigonometry will help to solve for that third side of your triangle, which will lead the plane in the right direction. The plane will actually travel with the force of wind added on to its course. This video is also brought to you by Globe. Try go lang ng go. We at Globe believes that today belongs to you. Wonders of trigonometry in airplanes. Although modern day engineers already has a faster way of determining whether there will be heavy turbulence in the flight, this wasn't always the case, and using trigonometric function is a good way of determining its velocity. Turbulence is an everyday hurdle that pilots and engineers have to account for, as this can affect flight path and several other factors that influence day-to-day flight. Pilots have to take into account the turbulence in order to determine whether they should use the tailwind or avoid a headwind in order to save fuel and ensure a safer, less rocky flight. If a pilot doesn't properly account for turbulence, it can lead to devastating disasters at most. Engineers also take into account turbulence when it comes to designing an aircraft so that it may be more adaptive and resistant to heavy winds. The significance of trigonometry. Bridge engineers incorporate trigonometry into design features. Trigonometry, the branch of mathematics that describes the relationship between the angles and lengths of triangles, helped early explorers plot the stars and navigate the seas. Nowadays, trigonometry is found in everything from architecture to zigzag scissors. While it may seem as if trigonometry is never used outside of the classroom, you may be surprised to learn just how often trigonometry and its applications are encountered in the real world. Much of architecture and engineering relies on triangular supports. When an engineer determines the length of cables, the height of support towers, and the angle between the two and the angle between the two when gauging weight loads and bridge strength, trigonometry helps him to calculate the correct angles. It also allows builders to correctly lay out a curved wall, figure the proper slope of a roof, or the correct height and rise of a stairway. You can also use trigonometry at home to determine the height of a tree on your property without the need to climb dozens of feet in the air or find the square footage of a curved piece of land. Trigonometry matters in sound waves. Simultaneously, the resulting sound is the sum of the two individual waves. Functions of the waves are added. Natural sounds have complex waveforms, but through the theory Fourier series, they can be regarded as being sum of pure tones, each of which is a traveling sine wave that produces a simple harmonic oscillation at any point, according to Greenleaf 1988. Two pure tones of the same amplitude are added together. Their frequencies are 450 Hz and 455 Hz. What will be the frequency of the resulting beats? Problem na to. Problem na. Problem na yan. Ito yung problem. The field of acoustic engineering may lead to a number of different positions related to the transmission and recording of sound. Acoustic engineers may consult with construction engineers and architects on the design and sound quality of facilities like performance spaces and recording studios, according to study.com 2017.
Excuse me, ma'am. I would like a library. I need it to be soundproof as well. So soundproof, in fact, that Metallica can play a concert right next to it and the noise wouldn't be heard inside. Could you get it done?
Yes, I could. According to the data that you handed me beforehand, there's 450 Hertz and 455 Hertz. And when you substitute it to the formula, it will be cosine 900 pi t plus cosine 910 pi t equals cosine 2 cosine 905 pi t and cosine pi t. This is the frequency, as you can see, which can be used for the task that you're giving me, and I will be able to use this in order to do so. You'll get it done soon.